Next is what is meant by the pressure in a liquid, like how the liquid exerts the pressure. So first of all, you can see here is a beaker that is filled with the liquid. If you put any object into this liquid, then there is a pressure exerted by the liquid. So I can simply say that a liquid will exert a pressure when any object is submerged in the liquid so that the object starts squeezing. Here I suppose that there is a stone that you submerged in that liquid. Then what will happen? The liquid exerts the pressure on this object. In this way, there is a pressure exerted by the liquid on any object. So I can simply say here, a liquid will exert a pressure when an object is submerged in it, causing the object to squeeze. So when the pressure is exerted by the liquid, the object squeezes. Forces against the surface of the object are produced by the pressure exerted on the object in the liquid. It is because of the reason you know that pressure is force per unit area. So the forces are produced only when the pressure is exerted in the liquid. These forces are always at right angle to the object surface. You also know that when you have to produce the pressure, the force that you apply on the object is always at right angle to the surface. So I can simply say that the liquid exerts the pressure when you put any object into the liquid, causes the object to squeeze, and the force against the surface of the object are produced by the pressure in the liquid that is exerted on the object, so that the force that are exerted in this case are actually at right angle to the surface of the object. So in this way, the pressure is exerted in the liquid. What would be the characteristic of the liquid that you have to fill in a container so that it will exert a pressure? So first is that the pressure acts in all direction. What does this mean? If I consider that it's a beaker that is filled with the water until this level, you place any object inside this. Then the pressure always acts in all direction. The pressure on this object would be exerted by all direction because this pressure is exerted by the liquid on this object. So the direction in which the pressure is exerted on the liquid here is very important because the pressure can be exerted from any direction. Second, the pressure basically depends upon the depth. If I consider that there is a liquid that is filled in this container and here are two objects. One object is placed at the bottom and the other object is placed at the top, at the surface of the water. Then which object basically exert the large pressure? This you can only tell with the relationship of the pressure with the depth. So just remember the relationship between the depth and the pressure, that pressure increases when the depth is larger. Like pressure and depth, both of these are directly proportional to each other. Next, we have to see the dependence of the density of the liquid on pressure. The pressure of the liquid also depends upon the density of the liquid which is filled in the container. If I suppose that I have two containers and these are filled with the liquid. First container has density, let's suppose it has density 1000 kilogram per meter cube. Second container has density 1500 kilogram per meter cube. So both of these liquids have different density. Which one of the following liquid exert the large pressure? It means that the pressure of the liquid also depends upon the density of the liquid. So from here, first thing is that the pressure acts in all direction. The pressure depends upon the depth as well as the density of the liquid. The pressure does not depend upon the shape of the container. It doesn't matter that what is the shape of the container, the pressure remains same. We will discuss all of these properties one by one. First of all, The pressure acts in all direction. It means that here there is a liquid that is filled here and an object I place here. When I place this object here, you can see by this red arrow, this shows that the pressure is exerting on this object, and this pressure is exerted by all the direction on this object. It means that in any liquid, when you place the object, then the pressure by the liquid is exerted from all the direction on that object. It's given here. The whole surface of the liquid is subjected to equal pressure and it is exerted in all direction equally. The pressure acts in all the direction equally. Here is a simulation that is related to the pressure, showing the property of the pressure in a liquid, that pressure acts in all direction. So let's open this. You can see here there is the liquid that is filled in it, and when I move the piston, like I'm going to move it here, you can see accordingly the pressure is exerted by the liquid and the liquid start flowing outside. When you goes on increasing the pressure, the liquid outside flows more. So by this you can simply say that when you exert the pressure, the liquid flows outside and it flows in all possible directions. You can also change the orientation of this body, like you can consider it in any direction. Then play this again, start increasing the pressure, then what will happen? The liquid exert pressure in all possible directions. So I can simply say that the pressure that is exerted by the liquid exert in all possible directions and it acts equally. You can practice this here. Dependence of the depth on the pressure. So first of all, here basically the pressure depends upon the depth of the liquid. I suppose that I have two objects, one is placed at the surface of this liquid and other is placed in some depth here. Then which one of the following object exert the large pressure? I suppose that it's the first object and this object is the second object. Then you have to tell me either the first object or the second object exert the large pressure. First of all, remember the relationship that pressure is directly proportional to the depth. Here I suppose that the depth is represented by the h. Pressure is directly proportional to the depth. By increasing the depth, the pressure exerted increases, and when the depth decreases, the pressure also decreases. Both of these are directly proportional to each other. It means that here the object that is in the depth at the bottom of this liquid, it will exert the larger pressure as compared to the object which is placed at the top of the liquid, which is at the surface of the liquid. It is because of the reason here for the object 1 the depth is very small as compared to the object 2. So I can simply say that here the order of the pressure increase is also given, that how the pressure increases with the depth. At the surface of the liquid, the pressure is lowest, and at the bottom of this liquid, the pressure is highest. It is because of the reason at the bottom the depth is larger, so that the pressure is higher, and at the surface of the liquid the pressure is smaller because here the depth is small. The same thing is given here. The pressure increases with increasing the depth of the liquid. When the depth of the liquid increases, the pressure also increases. The deeper the object into the liquid, when the depth of the object in the liquid increases, greater will be the force of the liquid above. Then if I suppose that the object 2, then there is the large force exerted by the liquid that is above this object. When the force is larger, according to P is equals to F over A, when force increases, accordingly the pressure also increases. So I can simply say that when the object is placed at a larger depth, the greater force will be acting here on that object by the liquid above it, so that when the force is larger, the pressure also be increased. That's why at the depth, the pressure is larger as compared to the surface of the liquid. So the same thing is given here, the deeper the object, the deeper the object into the liquid, greater will be the force of the liquid above and larger will be the pressure. Dependence of the density of liquid on pressure. How the pressure changes with the density of the liquid? Just remember that the pressure is directly proportional to the density. When the pressure increases, the density also increases. If I suppose that I have two liquid here, liquid 1 and 2. Liquid 1 has density 100 gram per meter cube and the second has 200 gram per meter cube. The density for both of these liquids are given. For which one of the following liquid the pressure is larger? So by this relation that pressure is directly proportional to the density, the liquid which has larger density, it will exert the large pressure. So it's the liquid 2 for which the density is 200 gram per meter cube. The density for the liquid 2 is larger as compared to 1, so that liquid 2 will exert the large pressure as compared to liquid 1. The same thing is given here. The density of the liquid is directly proportional to the pressure. Both of these are directly related with each other. The more denser the liquid, when the density of the liquid increases, the higher the pressure at the particular depth. When the density increases, of course, the pressure also increases. But if we talk about the depth, like if I say that the object, there are two objects, one object is placed here. So if I talk about the dependency of the depth on the pressure, I suppose that there are two objects that are placed at the same depth. Then for which one of the following object the pressure is larger? See that for both of these objects the depth is same. When the depth is same for both of these objects, the pressure would be the same. So I can simply say that for the particular depth the pressure is same. But if we here relate the pressure with the density, for the particular depth, the higher pressure would be exerted by the liquid whose density is larger. The pressure does not depend upon the shape of the container. Let's see this. The pressure remains the same either you are taking any kind of the container. I suppose you are going to take the rectangular container. After that you take the square container. You take the circular container. In all of these cases, the pressure does not change. The value of the pressure remains same because pressure does not depend upon the shape of the container. So the pressure at a given depth is constant regardless of the breadth or the shape of the container. So here the shape of the container does not matter. The pressure is independent of that. Which point exerts the more pressure? You can see here there are two containers and the different points are shown A, B, C and D. The one thing is given here, high density liquid and the low density liquid. Both of these liquid have the different density. If I say that it's the first container and it's the second one, container 1 has the high density and for the container 2 the density is small. Here we have to show that for which one of the following points A, B, C and D, the pressure is larger. So first of all, see the dependency of the pressure. The pressure is directly proportional to the density and pressure is directly proportional to the depth. First of all, we will see the effect of the density on the pressure. When the density is larger, of course the pressure is larger. It means that the liquid that is filled in the second container, it will exert the small pressure because here the liquid has a smaller density. So it's the container 1 that exerts the large pressure depending upon the density. After that, we also have to account the depth because here in this liquid there are two points A and B. Next, the point A lies at the surface of the liquid while the B lies at the bottom, means that at the larger depth. As the depth of the point B is larger than the depth of the point A, accordingly the pressure of the point B would be larger than the point A. So I can simply say here that the pressure exerted at the point B is larger than the point A because the B point is at the larger depth and in a liquid whose density is larger. So you can see here two identical containers filled to the same height with the liquids of high and low density. There are two liquids, one has high density and the other has low density. The 2 points A and C are at the same small distance below the surface of the liquid. Other 2 points B and D are at the same small distance above the bases of the container. Explanation for that is given here. The pressure depends upon the density of the liquid and the depth. Because pressure is directly proportional to the density and it is also directly proportional to the depth. So, the pressure depends upon two factors. One is the density and the other is depth. Higher the density, greater will be the pressure. When the density of liquid is higher, the pressure is larger. It means that the pressure of the first container is larger than the other because for the first container the liquid is denser as compared to the second one. Also, greater the depth inside the liquid, larger will be the pressure. When the depth increases, of course the pressure also increases. The point B has larger depth than the point A, due to which the pressure exerted at the point B is higher as compared to any other point. It means that here is the point B for which the pressure is larger because for that point the depth is larger as well as this point is in a high density liquid. That's why the largest pressure is exerted by the point B. Next, here is the formula that the pressure due to the column of the liquid. On which factor the pressure depends? We already see the two factors on which the pressure depends. One is the density and other is the depth. So here is another factor G. It is the gravitational field strength on which the pressure depends. Here you can see the formula. Delta P is basically the change in pressure. It is equals to the product of the density, the gravitational field strength and the change in depth. So I can also write here P is equals to density times the gravitational field strength and the depth of the liquid, where rho is basically showing the density and G is the gravitational field strength. Delta H is the height difference between the columns of the liquid and it is given in meters. Therefore, the change in pressure is measured in Pascal, means that the unit of the pressure is Pascal or Newton per meter square. So I can simply say from here the pressure due to the column of the liquid depends upon three factors. One is the density, second one is gravitational field strength and the third factor is the difference of the height or depth. Here you can see there is a animation that is related with the variation of the pressure with the density of the liquid and the depth. So let's open this. Here you can see that in the container some liquid is filled. You can also increase or decrease the amount of that liquid, just like that. Press here to decrease the amount of liquid and press here to increase the amount of liquid. After that, there is an instrument that is used to measure the pressure. I place this instrument at a different depth. You can see here at the bottom where the depth is larger, the pressure is 117.748 kilopascal. Above it the pressure is 111.372 kilopascal and at the surface the pressure is 101.543 kilopascal. It means that by increasing the depth, the pressure value also increase. After that, if I increase the density of that liquid, then what would be the effect on the pressure? See here I am going to increase the density. You can see accordingly the pressure value also change. By increasing the density of the liquid, the pressure also increase. I am going to decrease the pressure. Now you can see the value of the pressure also decrease. So I can simply say here the pressure is also depends upon the density of the liquid. The larger the density of the liquid, the larger would be the pressure. Next, what would be the effect of the gravitational field strength on the pressure? I am going to increase the gravitational field strength. You can observe the values here. The pressure increases by increasing the gravitational field strength. But if I decrease the gravitational field strength, the pressure also decreases. So I can simply say that by increasing the gravitational field strength, the pressure increases, and by decreasing the gravitational field strength, the pressure decreases. So pressure depends upon three factors. One is the depth of the liquid, second one is the density of liquid, and the third one is the gravitational field strength. After that, we can also observe here that the pressure is independent of the shape of the container. See here. First of all, I consider this shape. Note the pressure values. Now I am going to change the shape of this container. The values of the pressure remain same. If I consider the another shape, just like that, the values of the pressure remain same. The first one values is not showing because you have to display it here inside a liquid, and you can also display it inside a liquid. So the pressure value basically independent of the shape of the container. The pressure doesn't depend upon the shape of the container. The values of the pressure remain same. You can practice this as well from here. Let's go back. Here is the exam question that appeared in October-November 2016. The diagram shows a dam holding back water. The depth of the water is given 65 meter. The density of the water is 1000 kg per meter cube, and the gravitational field strength G is given, which is 10 Newton per kilogram. You can see here it's a figure that a dam holding the back water and the depth is 65 meter. What is the pressure exerted at the base of the dam due to the water? So basically here you have to calculate the pressure. Let's see the answers. Answer A, 15.4 Pascal, B, 154 Pascal, C, 65,000 Pascal, D, 650,000 Pascal. So when we have to solve this, see the data here. The depth is given, which is 65 meter. The density is also given, which is 1000 kg per meter cube. The gravitational field strength is represented by the G. Its value given 10 Newton per kilogram. You actually have to calculate the pressure. You know the formula that pressure is the product of density, gravitational field strength and the depth. Just put values here, you get the value of the pressure. So let's see the answer and explanation. Depth of the water is given, which is 65 meter. The density of water is 1000 kg per meter cube. The gravitational field strength is 10 Newton per kilogram. You know that pressure is the product of density, gravitational field strength and depth. Just put here value, you get the pressure, which comes to be 650,000 Pascal. So let's go back and see the answers. In the answer D, the pressure is 650,000 Pascal. It means that answer D is correct from here. You just need to use the formula of the pressure because all the data is given. You can easily calculate the pressure. There is another exam question that appeared in May-June 2018. A submarine is in water of density 1.0 times 10 to the power 3 kg per meter cube. The density is given. The submarine changes its depth. This causes the pressure on it to change by 0.10 megapascal. What is the change in depth of the submarine? So basically here the change in pressure is given and the density is also given. You have to calculate the change in depth. Means that when you apply this formula, change in pressure is equals to density times the gravitational field strength times the change in depth. You have to make the change in depth as a subject. It would be equals to change in pressure over density times the gravitational field strength. Now let's see the answers. Answer A 0.10 meter, B 10 meter, C 100 meter, D 1000 meter. So here you have to find out the change in depth. Let's see the answer and explanation. First of all, the density is given, which is 1.0 times 10 k per 3 kilogram per meter cube. Change in pressure is 0.10 megapascal and mega is basically 10 k per 6. So just write here 0.10 times 10 k per 6 pascal, because you have to consider the unit of the pressure, which is pascal. Here is the formula that is relating the change in pressure with the depth, density and gravitational field strength. Here D basically represents the density. Then rearrange this formula, put values here, you get the change in depth, which comes to be 10 meter. It means that answer B is correct. Let's go back and see the answers. The 10 meter depth is given in the answer B. It means that answer B is correct from here. Here are some questions for your practice. You need to solve these questions. Here is the question 1. A cup of the tea placed on the table whose weight is 4 Newton. The bottom of the cup has surface area 0.003 meters square. What is the pressure that the cup of the tea exerts on the table? So basically you need to find out the pressure from here. You are holding a book of mass 2 kg in your hand and the area of contact between your hand and the book is 20 cm square. Here the mass and the area is given. Determine the pressure exerted on your hand. You have to calculate the pressure exerted. The density of the water in the lake is 1.0 times 10 to the power 3 kg per meter cube. Calculate the depth of the water. You have to calculate here the depth at which the pressure is 42 times 10 to the power 3 pascal. So here you have to find out the depth of the water. Consider a liquid of density 1.5 times 10 to the power 3 kg per meter cube in a container. Determine the pressure due to the liquid at the depth of 0.034 meter. The area occupied by the container is 0.042 meters square. What is the force exerted by the liquid caused by pressure? So first of all, you have to find out the pressure due to the liquid. And secondly, you also have to calculate the force exerted by the liquid which is caused by the pressure. Next question is that a cubical box has dimension 1.5 meter by 1.5 meter. It's filled with oil of density 850 kg per meter cube to the depth of 5.2 meter. Determine part 1. The pressure exerted by the oil on the base of the cubical box. Part 2. The force exerted by the oil on the base of cubical box. Here you need to calculate the pressure as well as the force. Today's lesson is ended. If you find any difficulty, you can ask. Thank you.